Here's our second vocabulary word. Our second vocabulary word is segment bisector. A segment bisector is any line or segment that goes through the midpoint. So what happens, this line cuts my other line in half, so I get the two congruent parts. Now if we take a look at example 3 here, here's one that's backwards. Here I'm told the midpoint. So I'm told K is the midpoint of JL. And what I want to do is I want to find the endpoint. So just like before, let's visually see this. Let's graph this out. So I'm told K is at -1 and 2. I'm told one endpoint is over 3 and down 5. So here is L at -3 and 5. -5. So put my wrong ones in there. Let me try that again. 3 and -5. And then what I'm going to do is I want to find point J. I know point J is up here someplace. I just need to find those coordinates. So what I'm going to do is I'm still going to use my midpoint formula, but I'm going to work backwards. I know my answer. My answer is -1, 2, because that's my midpoint. So I'm going to say, oh, -1, 2. Then what I'm going to do, I think I'll call the coordinates of J, I don't know what they are, call that X and Y. So I'll add up my x's and divide by 2. So I'll say x plus 3 over 2. And then I'll do the same thing with y. I'll say y plus the -5, which is y minus 5, all over 2. Well, I'm going to split those up because I want to find x and y. So I'll say, oh, -1 equals x plus 3 over 2. Now we'll just do the algebra to solve for x. I'm dividing by 2, so I multiply both sides by 2. So I get -2, or times -2, I should say. So I get -2 equals x plus 3. Then I will subtract 3 from both sides. And I get x equals -5. Now I'll do the same thing for the y's. I'm going to split up my equation. So I'm going to say, oh, my answer, my y coordinate, my midpoint is 2. That equals y minus 5 all over 2. So I multiply both sides by 2. 2 times 2 is 4, equals y minus 5, because my 2 is reduced. Add 5 to both sides, and y equals 9. Now, that's the algebraic way to do it. Look at, it's kind of a lot of work here, isn't it? Let's look at this geometrically. So if I look at my graph, if I know my midpoint is -1, I know that's right in the middle. So in other words, from 3 to -1, what am I doing? Well, I'm going backwards 4, aren't I? So I'm going to continue to go backwards 4 on my x coordinate, and -1 minus 4, oh, that's -5. I'll look at my y's and I'll look at the same way I did that. I'm going from -5 to 2. So my y coordinates, I'm adding 7. So go from -5 to 2, we add 7. We'll continue to add 7. 2 plus 7, oh, that gives us 9. So my answer, algebraically or geometrically, how you do it, is -5 and 9. Now in example 4, it's kind of what we did on the previous lesson, except we're going to throw in something we won't know about midpoint. I want to know the measure of P to R, which I know is 14x plus 2, if Q is the midpoint of PR. Well, if Q is the midpoint of PR, I know QR and PQ are the same. So in other words, PQ is 6 minus 3x. Now I can use my segment addition postulate that we did yesterday and say, oh, 6 minus 3x plus 6 minus 3x, well, that equals to 14x plus 2. Now let's do the algebra. Combine your like terms. 6 plus 6 is 12, so I'll say 12. And then I'll combine my x's. Negative 3x minus 3x, that's negative 6x. equals 14x plus 2. Well, at this point, I want to get all the x's on the same side. So what we're going to do is we're going to add 6x to both sides. And so on the left side, I get 0. On the right side, 14x plus 6x, well, that's 20x. Well, at the same time, let's get all my numbers on the left side. So let's subtract 2 from both sides. So 12 minus 2 is 10. So to solve for x, I divide both sides by 20. So x is 1/2. But I'm not supposed to find x. I want to find the distance from P to R. Well, I know P to R is 14x plus 2, so I'm going to take 14 times 1/2 plus 2. Well, that'll be 7 plus 2, which is 9. And there's my answer. That's the distance from P to R. It doesn't give me any units, so I don't have to worry about units on this one.